So let's take a look at AI Foundry, the complete Azure AI toolchain, all integrated within a single platform. It's organized hierarchically with hubs, and within each hub you have projects. And from the menu you can see there's lots to explore. It includes functionality around building, observing, and governance, which are all great topics for a future session. It includes the Azure portfolio of AI services like speech, content understanding, translation, video, and content safety. Let's first look at the model catalog. Here you can see we have access to over 11,200 models. Well, that's a lot. How can we see what we really need? We can filter on various things, such as vendor, industry, deployment options, and inference tasks. There is also an agent to help us navigate the catalog and choose an appropriate model. And we can compare models, look at things like quality, accuracy, costs, latency, and so on. At the top, we've got various announcements from the AI Foundry team. One new announcement I can see, Grok 3 is now available in the AI Foundry. I can select the Grok 3 model, hit the blue deploy button, follow a few more dialogues, and Grok 3 is then available for me to use. If I click on My Assets Models, I can see what models I currently have deployed in my project. One model I have deployed is GPT-4o. If I click on this, I can look at various properties and information about its deployment. If I click on Agents in the menu, I can then see a number of AI Foundry agents that I currently have configured. Click this blue button and I can create a new agent. Give it an agent name. I then select the model I want to use. In this case, I'm going to use GPT-4o. I give it some instructions, the system prompt. I can point it at some knowledge so it can ground its responses. For example, I could have some information in some files, or if I use Bing, it can have got access to the whole of the internet. And I can point it at some actions, enabling the agent to perform tasks, typically by invoking code or APIs. Let's now look at each agent in turn and see how I've configured them with various items of knowledge and actions. I have a vanilla agent. It's a helpful assistant but has got no access to any knowledge or any actions. I have a Bing agent, similar to vanilla, but it's got access to Bing and so can access the latest knowledge from the web. I have an Alan Turing agent. It's set to "You are Alan Turing, speaking the first person," and it's using knowledge from a series of documents that's got all sorts of information about Alan Turing, such as his personal life and his achievements. I have the Titanic agent. It's got access to an Excel spreadsheet and has got information about travelers on the Titanic. I have an agent called Trailmaster. It's got some knowledge about camping information that is stored in Azure AI Search. I have an agent called Colors. It's got knowledge of an API service that can store and retrieve color information. So we have to give it the Open API or Swagger document. And my last agent, it knows about our Logic app. It can use Microsoft 365 to send an email. Let's now see these AI agents in action. I've created a simple web app that lets me connect to an agent and have a conversation. The code for this app is available on GitHub at markharrison/AI agent web. In the app, there's a menu option to view files I've uploaded to AI Foundry. Here we can see the knowledge files on the topics, Alan Turing and the Titanic passengers. Another menu option allows us to create an agent. I can do this either through the Foundry portal UI or by writing code directly. We can also list all available agents which match the list we saw earlier. There's an option to chat with an agent where we get a list of agents to choose from. For this demo, I'll select our vanilla agent. To connect to an agent, we have to create a thread. Essentially, this is a running instance of the agent. I'll ask it, who won the most recent FA Cup? Since the agent's knowledge only goes up to the training cutoff date, it provides the 2023 winner. Now let's try again using the Bing agent. This one knows about the 2025 winner and even provides a link to the relevant web page. Now let's have a chat with Alan Turing. Notice how the agent responds in the first person as if it was Alan Turing himself. Now let's explore Titanic survival data. I want to create a bar chart to visualize survival rates by travel class. We can see that 62% of the first class passengers survived, while unfortunately only 25% of the third class passengers did. Next, let's take a look at the agent that can interact with our Logic app, specifically the one that can send an email. I've asked it for an inspirational quote and indicated that I'd like it emailed to me. The AI agent recognizes that it has access to an email sending tool and it uses that. Let's wait a moment. Here it is. The email has arrived. Thank you, Steve Jobs, for your words of wisdom. Now let's take a look at the run history of our Logic app. As expected, we can see the same quote logged in the workflow. Moving on to our final agent, this one interacts with our Colors API, which stores and retrieves color data from a database. The code for this API is also available on my GitHub if you'd like to explore it in more detail later. One of the API operations lets us list all stored colors. When we run it, we see various shades of blue. There's another option that returns a random color. In addition to the API, we have the Colors web app. Again, the code is on GitHub. This app features a series of lights that at random intervals will call the API to retrieve and display a random color. As we watch, we can see different blues flashing across the lights. Now let's try using our agent. I've asked it to find the color of Watford FC's shirt and store that color. The agent knows that it has access to the API and it uses the appropriate tool to store the new color. We can see that yellow has now been added to the colors database. and we can verify here that yellow was added. Now, let's return to AI Foundry. There's a tab that displays all instances of agent threads where we can see the full message history, the conversations exchanged between the user and the agent. If we drill down into a specific thread, we can get even more detail. Here we can see which tools were invoked and the parameters that were passed during the execution. For example, this is where the color database was updated with the color yellow. In another thread, we can see the activity related to generating our Titanic survival chart. There are two tool calls here. The first call retrieves the headers from the data file, helping the agent understand the structure of the data set. The second call executes the Python code to generate the actual chart. And finally, in this thread, we can see our logic app being invoked. Parameters passed to the app can be seen, like the email content and recipient. In the next demo, we have semantic kernel orchestrating multiple agents. As before, the code is published in my GitHub for later perusal. We've got three agents, a poet, a color checker, and a manager. The system's prompts tell each agent what they are to do. The poet agent is told to create a funny poem about a provided subject. The color checker agent is told to detect if the poem contains a color, otherwise it is tagged as a dull poem. The manager agent approves the poem if told by the color checker it does include a color. The code specifies a termination strategy, when to stop and also to avoid endless loops. And the code also includes a select the next agent strategy. The agent group chat binds the multiple agents to work in a conversation together to solve the problem. So let's run it. Enter a poem subject. Let's try birds at the zoo. The first poem is rejected. The second poem is also rejected. Ah, good. The third poem is approved. It includes the word pink. The termination strategy determines the goal has been met, and so the process terminates.